Hey everyone, welcome to another DVIC Masterclass. I'm Julien Redmond from Ignition, and once again I have with me Michael Olschimke. Did I say that right,
I guess.
Michael? Yeah, from Scale Free in Germany, and Nols Ebersohn from Ignition in west of Hervey Bay. So, welcome guys. Thanks for joining again.
Thanks for having me.
Thank you.
All right. So as with last time, this is here to answer questions from the audience. So if you're watching either on YouTube or on the DVIC platform or through any other means, then please feel free to throw a question up to this esteemed panel, and we'll try and get to answer it. And if we don't get to answering it, we'll answer it in the next session. Which kicks us off for today. We have a handful of questions from last time, so we might just jump into it, guys. If you're ready to go, if your brains are warmed up. All right. First one is from Sakib, and the question is, what is the best way to capture the effectivity of a relationship in a many-to-many relationship? So, Michael, why don't you take that one to start with?
Right. So first of all, you find a lot of comments online how to do this with a load end date. So let's start with the anti-pattern, right? So there should be no timelines in the link itself other than the load date, and that's for the technical visualization. What we do is we use an effectivity satellite attached on a link to capture those either those business timers from the source or the one that you calculate in the business vault, or like a deleted date that we capture or calculate based on the physical existence or non-existence of the relationship in the source data set, essentially. So the standard pattern, Effectivity Satellite is not a special satellite or something. It's really a standard pattern. It's a standard satellite where we capture those timelines, and that's it more or less. The only change is typically to calculate the deleted date, to recognize the deletion in the source system, and that really depends on how the data gets being delivered, essentially.
Okay, so Nols, what problem is this solving for maybe for those in the audience who haven't been through the certification course? What's the challenge that means that effectivity satellites are needed?
We have a fundamental challenge with relationships in most implementations, in that the relationships are only hinted at. It's never properly actually described. So the relationships are neglected in a lot of business processes. So you get specific relationships like an event or something that may express itself as a relationship, and that's nicely described, and that's fantastic. But in general, most relationships are just hinted at. It's just a foreign key or some sort of reference to, oh, you may want to know that there's a relationship here, but it's never described really well in the design paradigms. So third normal form, which sort of the traditional approach to operational design, does have the relationship in there that there is a set of foreign keys potentially, but that's it. You don't know when it started. You don't know when the relationship changes. You don't know when the relationship has been deleted, to which Michael has alluded to. So the effectivity satellite is basically a set of derived data. So it's a business vault citizen. It's derived data because it doesn't exist at source. And so this derived data is an attempt to describe what is otherwise a poorly described entity as far as the relationship is concerned. And the issue there is, or the technique is to design or designate a driving key. In other words, which of these business keys participating in a relationship remains stable enough to evaluate the change in relationship over time. But Sagib asked a very good question. What about if it's a truly many-to-many relationship? In other words, there's not a single driving or identifying business key in the relationship. It's a true many-to-many. You can't use a driving key construct in those cases, but you can still use a business rule. Now, the driving key is basically a type of business rule. The results are business vault citizens because they are derived, that doesn't exist at source. So if you have a more complex business rule to unpack this relationship and bring other factors into its calculation as to trying to figure out when these relationships started and ended and all the rest, that rule could be as complex or as simple as necessary to deliver on that outcome. So the effectivity satellite is just capturing the descriptive details of that relationship in case of a poorly described relationship, which unfortunately happens more often than not. So that's the sort of the up and down of the effectivity satellite. As Michael pointed out, the derived data loads and is historized like any other satellite, so there's no special thing there. The special thing about effectivity satellites is just where does it come from? And it needs some sort of business rule, either a driving key of some sort or a more complex business rule.
One comment on this one. So I know there's some articles out there where they discuss to apply or combine effectivity satellites with driving key. But from my experience, to be honest, it's much easier. The thing is, when you introduce a driving key, you imply some business rule where you say, well, there's some precedence of some business key or something. But in Data Vault, all the links are end-to-end links, many-to-many links, right? So we don't have an M1 to M link or something, or 0 to, or some other cardinality essentially. So from that perspective, the only challenge when loading a effectivity satellite is really to identify if a record has been deleted or not. And that might be a challenge depending on the source mechanism, but in many cases, to be honest, it's not. So think about this. When you have full loads in staging or in your data lake, for example, those relationships which don't exist anymore in the staging area must have been deleted. That's maybe a bit naive in some source systems, but for the general, for reliable sources, it works actually. And then we just calculate set the load date of the run where we identify the deletion essentially as the deleted date. That's it. So I don't see a driving key problem here or a driving key issue here. So to me, it's also a hate-love. People who went to my training know that I hate the driving key, but I also love it when I need it. But here I don't need it. That's my experience essentially. So I wouldn't bring the driving key into the discussion typically. Yep.
But you need a business rule, whether it's a driving key or a different rule, or whether it's a comparison for delete detection or not. You need some sort of rule to derive what's missing. And I think the effectivity satellite's a good construct to capture what was otherwise missing from the relationship descriptors.
Yeah. Okay.
Fully agree.
Great. Well, that's good. I mean, and it would seem to me that the way Data Vault goes about managing relationships is so much more advanced than the traditional methods that we used. And and this is probably getting deep down into how we manage those relationships as they get a little bit more complicated. But the fact that we actually, within the Data Vault, describe those relationships and then capture the information around how the relationship evolves and progresses is, to me, it's one of the fundamental bits that we have. So. Okay, well, Saqib, thank you for that very interesting question.
If you look at other design philosophies, they either do not address the relationships or they lose them completely. So if you look at, for instance, the dimensional models, fantastic for where it's used as a slice and dice ad hoc reporting structure, brilliant for that. But it does lose the grain or the essence of what those relationships are. So that metadata, that understanding does disappear. And so it's one of those things where you're 100% spot on that the relationships being an explicit or a specific entity is the secret sauce to flexibility. And then that leads to a broader range of integration opportunities, etc., as we need to achieve for what a warehouse needs to do, the two jobs, right? Integration by business key in facts and their time context.
Yeah. And what I also think is the effectivity satellite on a link will help us essentially to capture all the changes to those relationships over time, right? So we don't lose any knowledge about how the relationship was in the past. And it's also an important check essentially when we design a data vault. Can you go back to the previous state? So you change the state from one, let's say, employee to one corporate car. They change the corporate car, but then realize the corporate car is not good. You want to go back to your old car. And then can you go back to the previous state without losing the fact that you have been using the new corporate car, which was not good for a while. And that's the important piece here.
Yeah, absolutely. Wow. Well, I mean, this is the masterclass. It's really nice to hear you guys dive into these things. And Sakiwa, if you've got follow-ups, then you can certainly reach out to either Michael or Nols through email. All right. So we'll move on to question number 2. Dehendra has asked, raw and business data vault can have historic data, but data retrieval rules performance is a crucial part. Is there any idea to reduce the data read to archive real-time data analytics?
Mm-hmm.
Oh, sorry, to achieve real-time data analytics. So, Nols, do you want to pick that one?
So the beauty of having both the raw data and the derived data as physical artifacts really available means you are already optimized to use the fastest database operation out there, reads. Now, the question here is saying, so what if we want to do reads and do them more frequently or to the point where it's real-time analytics? And so the secret sauce there is, of course, if your derived data cannot arrive at a real-time stream basis, then your performance may obviously have to wait for the necessary dependencies for the derived data to be available. But let's assume that both raw and derived data is readily at hand. If you want to have direct, minimal, equijoin type performance, then introducing a point-in-time bridge table that, based on events or triggers, are appropriately made available or tuned or tweaked, then in the very next time you read or consume your virtual information mart based on top of your point-in-time and bridge table will give you that instant access and minimize the number of reads and the direct access and optimizing whichever retrieval mechanisms your platform may or may not support. And so from that perspective, again, we mentioned in our previous masterclass session that point-in-time bridge tables are an important part of the tuning for performance characteristics at the consumption layer, but that is essentially the way that you minimize the number of reads and sweeps across the data and so on. Now, your mileage may vary depending on the tech you have available. So I'm just putting that caveat out there because some tech just don't allow equijoin or direct access, and your mileage may vary.
Michael, any thoughts to add there?
No, fully agreed. The only thing I would give it a different perspective. Think about this. We want to distinguish here between 2 different aspects here. One is the data ingestion. I fully agree with Nols. I agree on both sides here with Nols. But the data ingestion is really about getting the data, the messages from the message queue into the raw data vault. And it really depends on your database technology. Can the system, the infrastructure absorb all these messages in a proper time? So depends on your database, on your infrastructure, on how you scale it up and so on. What I would do is when we capture these messages, a lot of people try to model a real-time feed, let's say with customer records or something, as customer hub and customer satellites, and apply delta checks and so on. What we typically do is we capture real-time feeds as what they are, events. And typically we use a non-hysterized link to capture the messages first. And then once I have captured these messages in a raw data vault, I then start the second phase, information delivery. And that's where I also agree with Nols, where we introduce a PID table. And the PID table is cool in this regard, because the PID table is like a custom-built index that identifies those records which are relevant for your information delivery. And that's really a subset of the records from your incoming data feed, while the bridge table aggregates the data essentially to the target granularity. So that also reduces the amount of data or amount of information, amount of records being essentially pushed into the dashboarding tool. And then the second part is, right, for the dashboard, think about this. In strategic dashboards where we report over years, we look at data over years. But in real time, we often only look at, 240 seconds of the past essentially. And that's a super small PID table where we look at 240 partitions of snapshots essentially, and that's it. So relatively small. And now you could argue, well, the PID table, because we're loading, let's say we have 10 million customers in the hub, you would load 10 million records into the PID table partition every day, every second, sorry, not every day, every second. Or maybe 100 million customers. every second into the pit table partition. So the argument is, well, it's way too slow. On the relation database, I agree. But here's the thing. When we train the pit table concept, we show it on a relational database often. But nobody says that anything that we show on these trainings, on the bootcamp training, must be on a relational database. So what about the pit table, for example? Could be in memory database, for example, like Redis cache. I mean, you could do this in a Java array or a Python array or something. I wouldn't do it, right, because of scalability issues. But Redis cache, for example, scales like crazy, and that's essentially a MPP database, massively parallel cluster database. Has some transaction safety. It's good enough for us, and that's where we can also build a PRT table in memory. And then the cool thing is, while we deal with partitions on a relational database for performance reasons, to always insert full partitions and drop them, in memory you can just rename the snapshot timestamp, and then like shifting the last snapshot partition from the pit to the next second by just updating one field. And then what you do is you, when a new message comes in, typically you would recreate it or build the partitions afterwards, but here in memory, you just update the cell that's affected, the customer hash key essentially, where there was a change in the settler. You just update that reference to the delta. That's it, super fast. And that's how we built the pit tables, and use that then to retrieve the right records from the relational database, from a data lake, what else?
So is there still a place then for like a Lambda architecture or edge analytics, when you're trying to do real-time analytics, it seems like there's lots of architectures that support doing that on the edge, straight through for that need, and maybe into the warehouse for a summarized view. Would you do that, or would you leverage the pit table in memory?
Right. So what I would do is I would essentially have my enterprise data bus. That's the massive data store that collects all the data, batch data, but also real-time data. Which means I wouldn't separate the different data sets just because they're real-time or batch. Doesn't matter for me. So we just absorb this into one system. The one enterprise data bus might be a distributed system where you have, let's say, like the pit tables in memory and Redis cache, the rest of the data in the relation database, and so on. Right? Could mix and match of different technologies. Yep. So on high volume of data, you might even consider using a different database mechanism for capturing these real-time messages. But then use the pit tables to identify the records to be sent out.
Excellent. I mean, what an interesting area. Obviously, there's lots of organizations that are dealing with real-time, and then there's lots of near real-time as well, which is probably dealt with slightly differently to true real-time as well. Where it might be operating in an automated production line or something like that. So very interesting. Thanks to Hendra for that question. We'll move on, unless you had any other comments, Nols. We'll jump on to Ralph's question.
Just put my architect hat back on.
Okay.
You need to use your architectures for whatever is the appropriate use. So if you have operational needs that are truly operational, extremely focused on a particular element, for the high availability, the cost, the everything else associated to it, it may in fact be more prudent to actually have an operational feature in your ESB, your enterprise service bus, or something similar that actually gives you that capability, and let the long history, the analytics, the large corporate memory be in the vault. It still goes to the vault. It still is in memory. You still have those things, but there's practicalities and also budgetary constraints to real-time processing. It's expensive. And so bear that in mind. Can the vault do it? Absolutely. Has it been done? Absolutely. Question is it the best spend of your money as to which type of delivery architecture you are pursuing here? So just a little bit of we do appreciate and we do like Data Vault, but it doesn't mean the rest of the architecture principles are negated. So we need to make sure that our delivery is appropriate, or our architectural choices are appropriate to the use case. It has to have value to the business.
Yeah. Can we talk about ADI patterns here, or I've seen some crazy approaches where essentially either I mean, usually you have to have real-time data feeds coming in, right? So we can't get real-time data out of batches, essentially, right? So there must be some real-time feeds coming to the data warehouse so we can have a real-time dashboard, essentially. We can only report as fast as the data arrives. That's the idea. And with some cases where I remember one project where the firm that was implementing the data vault essentially was implementing a very sophisticated actual real-time system, but there was no need from a user base, from a user standpoint, to have that actually. So that was complete overkill essentially for the requirements. Nobody needed the data, the reports in real time, but they built this essentially. So that's really overkill. Yeah, fully agree.
Absolutely. I mean, you don't want to be notified the very second someone changes their address. It's it's unlikely to be super important at that level. So
well, unless you have a hailstorm coming in, right?
Yep.
But you can hear the rain. It's hitting. So, anyway, if I disappear, it's because the power's gone out. But we do have quite a storm hitting. All right, we're going to move on because that was a good deep dive, but we've got more to go. So Ralph asked a question. And so, Nols, I'll ask this to you to start with. Do you see a relationship between data lakehouse using open table format like Delta and Data Vault? And if so, what's the relationship?
That's a very good question. I'm going to ask or relay a similar question that comes through quite often. Will Data Vault work, or will Data Vault work on technology X or Y or platform X or Y, whatever the case may be? And I always come back and say, as long as the platform or technology supports the analytical workload, not Data Vault, but the analytical workload. Can you join? Can you find? Can you integrate? Can you make it appropriately available? Do you have ways or mechanisms to facilitate the functions, the leads, the lags, the table-based functions, your recursive, your hierarchy management, recursive CTs? So the question really then comes up: does your technology support all of those features and functions? And if they do, happy days, you have a solution. To a bit more specifically on the lake house and the Delta Lake and all those type of components, do they deliver on some of the features that we need for the vault? Absolutely, they do. Do they necessarily behave in all the same ways that we traditionally have done for a data vault? Sometimes, sometimes not. You will have to check on your technology as such. So, I mean, Michael and his team has done some fantastic work on some really interesting and challenging platforms in the past. It requires a deep knowledge of those platforms, but can it work? Sure, it can. But here's the thing: our usual lake house kind of functionality does well with the delta detection. That's typically well established and so on. Does it do very well with the integration? And unfortunately, unless there's a conscious design decision to drive out the integration around business keys and relationships, that doesn't necessarily happen. So that's the critical bit where Data Vault remains relevant irrespective of the technologies that are coming in play. Does some of them make it a lot simpler and easier to do? Absolutely. And so leverage those, please do. But do not forget, we are dealing with information, and information don't care what technology you run. The principles, the building blocks of information management remains immutable in the situation. So we need to deal with the fundamental requirements, integration by business key, the facts in their time context. Those things are immutably required. So can we use a lakehouse? Can we use the other import or popular terms out there, the medallion architecture, etc.? Absolutely. Those type of architectures have been supported by Data Vault since day dot. So things like medallion architectures, where the separation between raw and derived data becomes a bit more pronounced, a bit more defined, is fantastic. We call it raw vault and business vault. and so they may go from bronze and silver or silver to gold, whatever mechanism they or whichever pattern of these medallions are being discussed in time. But the bottom line is those principles, those architectural principles, do play out well, and that's fantastic news because at last the industry is catching up to where Data Vault's been for quite some while. Sorry for being somewhat
Absolutely.
biased in that opinion, but there you go.
No, I love it.
No, it's, one comment or longer comment. The keyword for me was principles. I was just jumping in, but I said, okay, let's let's leave notes to talk out. The thing is this: we teach data vaults in a training always on relational database. So we have hub-sync satellites, and we discuss all these special entity types and so on, joining them for dimensions and so on. That's all good, but how the data vault looks like on the implementation wise really depends on the platform. But I think, so give you an example. Let's go for some extremes. I truly believe, I've never tried it, you could build a data vault in an Excel sheet, in a spreadsheet. Should work. Never tried this. I don't recommend this, just saying, but it should work. But we could also look at some other extreme databases like, for example, MongoDB. MongoDB is not a relational database. It's a document store. So it deals really with documents, JSON documents in a collection, essentially. That's it. There's no relation or table or something. And when you look at how a data vault looks like on a MongoDB, we have collections for hubs and links, but not for satellites. I leave it open how it works out. There's a blog series on our blog where we describe essentially how to build a data vault on a MongoDB. But it was quite an interesting challenge because it's completely different. What you realize, though, is there are satellites. The concept of the satellites, the principle, still remains. So we have that. Data vault is in the first step. It's not about hub-sync satellites. It's about business keys, relationships between business keys, and descriptive data. Those are the core concepts, essentially. And then how we implement this using hub-link satellites depends on the technology that we're using. If it's an Excel or a relation database, on a MongoDB, JSON collection, and so on. But the principles remain the same. And those principles, they meet your requirements. Because I agree with Nols, if you have a different solution, go for it. If it's sufficient, meeting your requirements. So if you, in some cases, seriously, in some real-time cases, we just dump the data in the feed. There was no integration, we just aggregate the data and we were done. If that's sufficient, if that's the requirement, so be it. That's one of the few projects where I didn't use Data Vault, where I actually recommended the client not to use Data Vault, because they just want to aggregate some data. If that's your goal on the Delta Lake, go for it. Just dump the data, aggregate it. But if you have more requirements than that, maybe you have to delete records. You have to integrate data from different source systems. The principles from Data Vault, they are still valid on any platform because they are related to your data, not to your platform. And so the only thing is, the Data Vault on a data lake, Cloudera, Databricks, whatever, would be a bit, or looks different to a relational database. For example, the joining performance is typically lower, not because it's a data lake, but because we often use column-based storage, which is also true for Redshift, for other databases. In this case, you want to avoid joins on high volume because they will not perform. And that's why we essentially rely on bridge tables where we denormalize data, rely on avoiding satellite splits if we can. If there's no requirement for it, we avoid them, right? And so on. That's the basic idea. But the principle is the same. That's the keyword here.
So I think obviously the principles of Data Vault have always applied to multiple technologies.
Yep.
I have a feeling this question's come about because obviously I watch what other vendors are saying and what other consultancies are saying, and there's certainly a big shift towards Lakehouse as a I guess a newer way to apply what used to be the combination of a data lake and a data warehouse together. So now it's kind of all in one platform, and we've certainly heard people represent that this medallion architecture is an alternative way to organize your information, an alternative to Data Vault or what have you. And I think the what we're saying here is it's not. It's an architecture. Obviously, Data Vault has 3 layers anyway, so the architecture and the model and the methodology components. The Data Vault will fit into that medallion architecture perfectly, and it'll actually work.
Mm-hmm.
And in fact, Data Vault's always been a 3-layered architecture, and And so the fact that medallion architecture is a 3-layered architecture that defines, raw, curated, and the delivery data aligns perfectly. So, I'd certainly say that you not only can you do it, but it's actually going to work well. Is I think the message. So, I think we've wrapped up that question. Any other thoughts, Nols or Michael?
I just posted a article we wrote on the Microsoft Tech community on Databricks, where we also have a diagram how the medallion architecture fits essentially on, or Data Vault fits into the medallion architecture of Databricks.
I've seen that one. Yeah, it's a great article. Yeah.
Yep. Cool. Thanks.
We'll make sure that's in the feed in DVIC. So really good point, Michael. If you're watching this right now and you're not a member of the Data Vault Innovators community, it's free to join. Jump on, sign up, and you can access not only these sorts of sessions, but lots of additional content, case studies where you can hear from actual people using Data Vault, and then, as Michael said, lots of articles and knowledge, knowledge base, and even reach out to these guys and ask a question through that. So, all right, we're going to move to the last question we have for today, because I think we've probably got about 10 minutes to go. So Lorenz has asked a question. It'd be really interesting to learn about effective approaches for managing deletions, including operational deletions related to GDPR, both in Raw Vault, but particularly in Business Vault and Information Marts as well. So, Michael, being that you are our resident European here and probably the most exposed to GDPR, we're going to start with you.
Okay, cool. So first of all, I would distinguish between operational and GDPR-related deletions. So operational deletions, let's say you're using Data Vault for a more operational system, I would try, if there's no legal requirement or organizational requirement to delete data, I would just avoid that. I would just historize the data as it comes, essentially historize it in the Data Vault, that's it, in the raw Data Vault, and that's it. If there's an organizational requirement or a legal requirement that you have to delete data, for example, when a consumer exercises the right to be forgotten, and you can complain to or you can essentially talk to the you can exercise the right to be forgotten, and in this case you have to delete data because there's a legal requirement. The thing is that in this case, the key principle here is separation. You have to separate the personal data from the non-personal data, or let's say in more broad terms, there might be more classes than 2 classes. The easy game is if you have 2 classes, non-personal data, personal data, but you could have as many classes you want. You have to separate data by each class essentially. So that's number one. And to be honest, we typically simplify it a bit in saying by privacy class, but to be honest, it's actually by data retention period. So if you have, let's say, one set of personal attributes, but some attributes you can keep longer than the other ones, you have to separate by data retention periods. That defines a class essentially. And then we separate the data column by column, essentially using a satellite split, at least in a relational database. And then the trick is essentially to delete the data when essentially consumer request comes in. We delete the deltas for this particular customer from the personal satellite. For the Business Vault and for the Information Mart, it's easy as long as you virtualize. Because the only thing what you have to do is afterwards, you have to drop after the deletion of those deltas, you have to delete drop the partition from the PID table and rebuild it. It will activate the ghost record and anonymize your customer dimension member, essentially. That's it. Problem solved. If you materialize data, one requirement for the Business Vault is that you can always truncate the table and rerun the business rules. You should come up with the exact same data in the Compute Satellite, in the Business Vault, for example, and so on. Which means that if you build your solution fully incremental, you can always delete certain, like those records belonging to the same hash key as the consumer. Just delete those records from the materialized Business Vault entity and restart the process of loading the data incrementally into the target entity. That should rebuild those entity records. And essentially, because you can't find a description, let's say you're using some personal attribute for your business rule, so be it. If you're using a PID table in this regard, the pit table would activate the ghost record from a satellite, and you're working with defaults in your business rule because that's the only thing you have. You don't know where the customer came from, or let's say what the last name was of the customer, because it's forgotten. So you have to work with defaults. That's what it is. So that's the basic principles. Separation is the key.
Yeah, absolutely. And that sounds like the last part of the question was some insights into automating that process would be greatly appreciated. I think you've probably covered on that. Nols, did you have anything to add?
One of the elements for that automation is you need a register that says, please forgive me. I mean, it's the first fundamental. You need to know which business key or which person or which person is asked to be forgotten.
Yeah.
And so most organizations, well, at least I can speak to the Australian New Zealand context, no organization has that register at all. So although GDPR legislation do apply down under, that first sort of hygiene factor of have a register, know that this is a request, know that you need to be compliant to this, and then you can appropriately architect and build accordingly. So there's a fair bit that goes into that process, not just from a warehouse or a information management perspective, but it has cascading effects in your operational systems and so on as well. So the interesting challenge is that your data warehouse, your data vault, is your corporate memory, and now you need to institute selective amnesia. And then this is only if there is no outstanding court cases or investigations, and so all of these things need to be washed against quite a few other checks and balances before we can just go, okay, fine. Now, Michael has very nicely identified the first rule of success for GDPR is and isolate the things that are the truly sensitive elements, and that becomes a very small problem to deal with. The rest of it's still relevant. We never get rid of any of the references to a particular business key in the relationships they participated. You may make those relationships inactive, so your effectivity satellites will come back into play, and so your sophistication around the rules around what is considered to be deleted or not then comes into play. And so we've got quite a bit of additional cascade of some of these effects. The best thing is let your source systems actually give you or guide you into what these things should be, what is the behaviors around them. And if you do get a delete, is this in fact a GDPR delete, or is this in fact an operational delete where it's legitimately just deleted, it was wrong kind of activity. So it does add a little bit of complexity in the event types, and our traditional approaches or our traditional tools for CDC, change data capture, doesn't necessarily give you that insight at this stage. You may simply get a delete, and you'll have to wash that against your register. So there's some practicalities to bear in mind. It's great to try to wrap your mind around how the GDPR behaviors need to be in the vault, but don't forget about the hygiene, the back-end components that needs to be in place to make this actually feasible. 2 cents worth.
Yep.
Wow, it's such a big topic too. I mean, I know, Michael, it's probably a bit different for you guys in Europe, but down here we're doing lots of PII assessments, so the personally identifiable data assessments, to help people understand where that PII data actually is right now, because we've got lots of people who don't really know where they're storing all of that information, and so, as you say, getting a good view of it to start with. I suspect you're probably a fair bit further on, being that GDPR is applied in Europe.
Yeah, we got some good experience here.
Yeah. So I mean, obviously, part of the value of this community is actually like leveraging the things that are happening in different regions. You know, GDPR applies to a lot of companies down here because they also operate in Europe or have customers in Europe and those sorts of things. So we're definitely got lots of organisations that are aware of it, but I think we're not as mature in that front. So. Look, that was only 4 questions, and we've been going for 40 minutes. So we're going to wrap up here. But I was thinking just quietly that we could probably create a drinking game around this session, because anytime we had a rooster crow or someone got distracted or there was thunder going, maybe so maybe we have the Data Vault Masterclass drinking game. Just an idea. Uh,
Don't ask a German for a drinking game, though.
yeah, 6 kinds of beer.
Yeah, water, right? We drink water here.
Water. Okay, all right then. Well, guys, thank you very much for joining. For everyone watching, if we obviously didn't get to your questions because we only got through the backlog of questions, but if you've dropped a question into the feed, then we will get to it next time. If you have any other questions, you can put them into the community, and we will pick them up and answer them as well. So we'll be doing this every month. As I said, please get onto the community and set up a profile and register and start interacting. And guys, thanks for joining this time.
Thank you.
Thanks for having me.